Okay, so in this Newton's Law of Review question, it's somewhat of a qualitative question, but it also has some quantitative pieces to it as well. So we've given a free body diagram for a cart at one instant in time. All the forces have been drawn to scale, so it's on a quantitative grid here. And what we first have to do is sketch a diagram of the cart string as they will appear in the laboratory at this instant, and then make a conclusion about what we can say about the motion of the cart based on the free body diagram. So what we can tell here is that the net force on the cart in the y direction is 0. So there's 1, 2, 3, 4, 5, 6 boxes in the weight, there's 3 boxes in the normal, and there's 3 boxes in the tension in the y direction. But since the normal is upward, vertically upward, I can assume that the cart is on a horizontal surface. So if I were to draw a sketch and think of the cart on a horizontal surface, and what we can see here is that the tension has an x component of 3 boxes to the right and 3 boxes in the upward. So this tension is at a 45-degree angle if you want to be a little more quantitative. So I will draw the tension force at a 45-degree, this string at a 45-degree angle. And this is where the string is. So I think that would satisfy the second bullet point, that we've drawn a sketch of the cart as it would appear in the laboratory. And then the last question we're trying to figure out, what can we say about the motion of the cart? Is it moving to the left, moving to the right, or is it stationary? So what can we tell about from the free body diagram? What we can state is that the net force on the cart in the y direction is 0. So again, repeating that we have 6 boxes of magnitude in the weight, 3 boxes in the normal, and 3 boxes in the tension. And then the F net on the cart in the x direction is equal to 3 boxes. Well, at least in a sense, I'm not sure what these units are, but there's no friction force on the cart, but there's a x component of the tension is not balanced by anything in the negative x, so there's 3 boxes to the right. So what we can state is, say, from Newton's second law, that F net equals ma, is that we can state that the cart is accelerating to the right, but note again that the acceleration does not tell us anything about the actual velocity. It only tells us about how the velocity is changing. So the cart could be moving to the left and accelerating to the right. So this is a valid answer. The car could be moving to the right and speeding up, or it could be stationary and have an instantaneous acceleration to the right. But the only thing that we can definitively state is that the car is accelerating to the right. So it could be moving to the left, to the right, or the car could be stationary. It's not possible to tell the direction of the velocity when we only know the direction of the acceleration. Acceleration can only tell us the direction of the change in velocity. So all of these 3, moving to the left, moving to the right, or stationary, are all valid. The only thing we can state is that the cart is accelerating to the right.